Students, in this video I want to discuss about the IUPAC nomenclature of coordination compound. IUPAC nomenclature of coordination compound. I have taken examples of two different type of complex here. One is called positive complex. Here you can find in this complex the coordination sphere is positive and therefore the negative ion is there as the counter ion, and in this complex the coordination sphere is negative and the counter ion is positive. So therefore it is called negative complex. So I have taken these examples to initiate because there are few rules, IUPAC rules of naming method. First one is that for a complex the positive part is named first. So for this complex, since the coordination sphere is positive, it is named first, and in the naming process the ligands are named. These are the ligands. They are named in their alphabetic order, and if there is multiple number of the ligand, same ligand, then if it is 2 then di, if it is 3 then tri, di, tri, tetra, this kind of name is written. So for this complex you find that amine, tetraamine, which is starting with A, and follow that in the name of amine there is 2M. In any other kind of form of amine, say methylamine, like that, there only one M is used, but in case of NH3 it is double M. So it is named as tetraamine, then H2O, aqua. Again it is starting with A, but alphabetically Q is coming next to M here. That's why it is named second. And then nitrito N, NO2, nitrito N, cobalt, that is the name of the metal, and then the oxidation number of this metal is 3, because in the complex there are total, you find that this is neutral, NO2 minus ion and 2 Cl minus ions are there. So in total there is 3 negative ions. Therefore the cobalt ion, central metal ion, is having oxidation number 3. Therefore it is written in the parenthesis in Roman 3. Next, chloride. So as a whole the name is, this is the positive part named with alphabetic order of ligand. First tetraamine, aqua, nitrito N, cobalt 3, then the counter ion chloride. Follow here, this counter ion is having 2 counter ions, 2 chloride ions, but it is not written dichloride, it is written only chloride. Therefore when we will write the name of the counter ion, we will not write there, if they are in multiple number, we do not write di, tri, tetra, etc. Now follow in this example of negative complex. Here outside the complex coordination sphere it is positive ion, so the complex part is negative. Therefore according to the first rule, the positive part is named first, that is it should be named with the potassium first. So potassium, then this complex part is written first, the name of the ligands in alphabetic order, then the metal ion. So it is named as potassium, then pentacyanide. This cyanide group is also called cyano. Previously it was called cyano. Still it is continued with cyano, but actual rule is cyanide. So potassium pentacyanide, then nitrosyl, NO, which is a neutral group, nitrosyl, then ferrate. Why ferrate? Because the complex is, when negative, the name of the central metal ion ends with ATE, the Latin name ferrous. In that we add the word "ate", so it is ended with "ate". So the name is ferrate, the metal ion is ferrate, and the in parenthesis the oxidation number of iron is 2. Here you can follow in this complex there is 5 negative ions, NO is neutral. Since potassium plus 1 and total is 3 plus, so this iron is plus 2. In this way, you can follow in these two compounds, the positive ligand, positive complex and negative complex are written. So this will be followed. Another example I have written here, it is En. En means ethane 1,2-diamine. Now this En is a complex ligand. So when we write the name of a complex ligand, then it is written in parenthesis, and if it is multiple in number, then instead of di, tri, tetra, we use bis, bis for 2, tris for 3, tetrakis for 4, in this way. So this complex is named as tris, this ligand, ethane 1,2-diamine. Then the metal ion is chromium, its oxidation number is 3 ion, chromium 3 ion. It is a positive charge ion, in the form of ion it is written. So chromium here 3 plus, because En, ethane 1,2-diamine, is a neutral ligand. Next, in this complex, it is dichlorido, so alphabetically chlorido comes first. Then the complex ligand PPH3, it is triphenyl phosphine. So it is also in multiple number, 2 triphenyl phosphine group is there. So it is named as bis, then in the parenthesis triphenyl phosphine, nickel 2. 2 is the oxidation state of this nickel ion here, because it is neutral. Chlorine is each one minus, so total 2 minus, so nickel must be 2 plus. So these are the few examples. Now to go on writing the name of the different complexes, we need to know the name of the ligands. First of all, we need to know the name of the negative ligands, that is end in O. Means if the ligand, original name of the ligand ends with ide like chloride, ite like chlorite, ate like sulfate, so it should be changed to, in the IUPAC system, in the complex, as ido, that means chlorido, bromido, this E and this E will be replaced with O. So like here you find Cl minus chlorido, Br minus bromido, F minus fluorido, earlier it was called fluoro, now it is called fluorido. Then I minus iodo, OH minus hydroxido, earlier it was called hydroxo. N3 minus, it is azide ion, so it is named as azido. Then NO2 minus, this is nitrite ion, it is linked with, it is an ambidentate ligand, it is when linked with the metal through nitrogen, it is called nitrito N, and when it is linked with oxygen, it is called nitrito O. Then H minus hydrido, SCN minus thiocyaneto. This thiocyaneto has, it is also ambidentate. There is possibility of SCN, NCS is possible. So when it is NCS, I have written NCS, no I have not written, NCS is called isothiocyaneto. Then Cn minus is called cyanido. Earlier it was called cyano, still cyano is taken as correct. Then N, it is an ambidentate ligand, NC minus, isothiocyanidо. So next C2O4 2 minus called oxalato, in short it is called OX, ox. SO4 2 minus sulfato, O2 minus oxo. Then O2 2 minus paroxo. CO3 2 minus carbonato, P3 minus, this is phosphide ion, so it is named as, in complex, phosphido. Acetate ion is named as acetato. NO3 minus nitrate ion is known as nitrato. NH2 minus amide group, it is named as amido. NH2 minus, it is imide group, it is named as imido or imido. N3 minus, it is nitrido. Nitride ion in complex, it is named as nitrido. Then S2O3 2 minus thiosulfate ion, it is known as thiosulfato. In this way, the negative ligands are named in the complex. When we write the name of a complex, in the complex we write the ligand's name like this. Now let us take some examples of positive ligands like NH2NH3 plus. It is named as they are ended with ium. Okay, so it is hydrazinium ion, so it is hydrazinium. NO2 plus, it is called nitronium. NO plus, it is called nitrosonium. These are some positive ligands. And the negative, neutral ligands, there are some neutral ligands used in the complex compound, which is neutral ligands are named as such. As their name, it is written in the complex, like CH3NH2, it is named as methylamine. Now this is CH2CH2NH2NH2. So it is ethane. You can follow that. If it was ethane CH3CH3, the hydrogens are replaced with two amine groups. So it is named as ethane 1,2-diamine, or it can also be stated as ethylene diamine. In short, it is written as EN. Next, it is pyridine C6H5N. It is pyridine. Pyridine is the name, and in short it is written as, in the complex formula it is written as PY in short. Then phosphyl. So these are few neutral ligands. Now there are some neutral ligands which are very frequently used. They are having some exceptional names, like H2O is written as aqua. Earlier it was written as aquo. Still in some books it is not changed, but right now the actual rule is aqua. Now NH3 is written as amine. Here the name you can follow. There are two M is used in the name. Here you can follow methylamine. Only one M is used. So this has to be noticed. Then CO, carbonyl. NO, nitrosyl. CS, thiocarbonyl. These are some exceptional neutral ligands. Now using these ligands, we can practice naming of some complex compound. I have written some examples here. Say it is K3Cr C2O4 whole 3. C2O4 is oxalate ion. Now you can follow, students, that it is a what kind of complex? Since counter ion outside the coordination sphere is positive, so the complex is negative. So we can follow, we have to start with the positive part, that is potassium. So potassium, though it is in 3 potassium ions are there, but we don't write the counter name, counter ions in multiple number as di, tri, like this. So we only write potassium. So it is potassium. Then the name of the ligand, trioxalato. Trioxalato. Then chromium. Chromium should be written as chromate since the complex is -1. So it is written as name of the metal as chromate. 8 is added and its oxidation number is 3 because oxalate is having valency 2 minus. So in total it is providing 6 minus. Potassium is providing 3 plus. So chromium must be 3 plus. That's why its oxidation number is written in Roman 3. So the name is potassium trioxalato chromate 3. Then it is CO. CO carbonyl is neutral ligand, so it has got no charge. So the name should be, it is a neutral complex, you can say. It is named as tetracarbonyl nickel 0. You follow that oxidation number of nickel is 0 here. It is not, there is no positive negative ions are there of the ligands. Therefore, nickel is also having zero oxidation state. Now in this complex, the counter ion is positive, so the complex is negative. It is named as sodium, not trisodium, sodium tetracyanido or cyano, then nickelate, but its oxidation number is 0. Why? It must be 4 here, as because I have written the oxidation number 0. That means 4 cyanide group providing 4 negative charge and 4 sodium ion is providing 4 positive charge. So nickel must be neutral. It should not have any positive charge. Now if we follow some more examples, like say so if we write this complex, here you follow that this complex portion is positive because outside there is counter ion is negative. What should be the name of this compound? Now alphabetically, amine starts with A, chlorido is next. Now you follow that when we are writing the name of the complex portion, it is positive part, but we should not write the name of the metal first. We should name the ligands first and also in alphabetic order. So it should be tetraamine dichlorido, then chromium, then we should write the oxidation number of chromium. You follow that it is neutral, Cl providing 2 negative charge total and NO3 is minus, total 3 negative, so chromium is 3 plus here, so it is chromium 3, then outside the counter ion is nitrate. We should not write the counter ion's name as the name followed that I had shown you as nitrito. It is written as nitrate, the original name. The name of the ligands is changed here within the coordination sphere only. Likewise, if we give a name, say name of a compound, complex compound, and we have to write the formula, say potassium trace ethane 1,2-diamine cobaltate 3. So when a name is given, you have to write the formula. First, we'll write the third bracket. Then, in this case, the process is reverse. Means we should write the formula of the metal ion first. Then, it is tris ethane 1,2-diamine. Ethane 1,2-diamine. It is written in short as EN. So it is tris, means 3 numbers are there. Now you follow that if I write this compound as the correct one, then you can follow that this En is a neutral ligand, and this potassium, that it must be written in the outside part as a counter ion, it is also positive. So in that case there is no negative charge in the complex. That means this name has got some, it is not correct one. So rather, if we change the name as tris ethane 1,2-diamine cobalt, COBALT, 8 should be removed, cobalt 3, say chloride. So in that case, the complex is becoming positive one. Since there is no negative ions in the ligand, it is neutral one, and we are given the name after the metal. The name is chloride. Then how many chloride we should write? Follow that the oxidation number of metal is 3. So to balance this 3 positive charge, there must be counter ion 3. In this way, we have to practice naming of the complex compound. Many of the complex compound we have to practice. Through practice, we can learn the other rules also. All the rules I have not explained here. It may follow in the next videos. And in this way, we should practice writing the naming of the complex compound, as well as writing the formula from the given name of the complex compound. Thank you.